Imagine you have an idea for an app, like right while you're drinking your morning coffee. Just this spark.
Yeah, like something to solve a tiny, hyper-specific annoyance in your day.
Exactly. And by the time you sit down for lunch, that exact app is entirely built.
Completely finished.
Yeah, it's debugged, it's hosted on a live server, ready for actual users. And the total cost to get it there was, about the same price as that coffee you drank while dreaming it up.
Which is wild because, for a long time, the friction between having an idea and shipping a product was just immense.
Right.
You either needed significant capital to hire a team, or you needed to sacrifice months of your life learning the rigid syntax of a specific coding language just to build a prototype.
Which most people just don't do.
No, they give up. But today, the landscape has fundamentally shifted.
Yeah, and that's exactly why today we are ignoring the endless Washington policy drama to focus purely on the builders. Right. We have a massive stack of updates to get through today. I mean, from Anthropic altering the pricing math of the entire industry to these staggering capability leaps from Qwen, OpenAI, and a whole wave of startups. The mission for this deep dive is to understand what this suddenly cheaper, agent-ready AI unlocks for you, for people who are trying to build things right now.
Because we are seeing a convergence of raw capability and accessibility that is just reshaping what a single person sitting at a laptop can achieve in an afternoon.
Okay, let's unpack this, because we have to start with the biggest drop of the week, which hit the developer ecosystem today, June 30th, 2026.
Yep, the Anthropic release.
Yeah, Anthropic just dropped Claude Sonnet 5, and they are branding it as their most agentic model yet.
Agentic is the keyword there.
Right. When we say agentic, we should clarify that we aren't talking about a chatbot where you type a prompt and it spits out a script for you to manually copy and paste.
No, not at all.
Sonnet 5 is built for autonomous planning and tool use, specifically across your computer's terminal.
And giving an AI access to your terminal is a massive line to cross.
It's the keys to the kingdom.
It really is. The terminal is the command center of a computer. When a model has access to it, it isn't just generating text anymore. It is actively driving the machine.
Right.
It can execute commands, install missing dependencies from the internet, spin up a local server, and most importantly, it can see the error messages when the system inevitably pushes back.
And Anthropic is actually backing this up with some pretty heavy numbers. So Sonnet 5 scores 63.2% on agentic coding benchmarks.
Which is huge.
Right. To put that in context, the previous version, Sonnet 4.6, only scored 58.1%. So it's a massive jump, and it's even approaching the scores of their heavyweight model, Opus 4.8.
Yeah, Opus was at, 69.2%?
Exactly. But Sonnet 5 actually beats Opus on subtle judgment tasks. Plus, they're reporting lower hallucination rates, lower prompt injection rate.
Which means it's much harder to trick the AI into bypassing its safety rules with a malicious prompt.
Yeah, and less sycophancy.
Now, that reduction in sycophancy is crucial for a developer tool.
How so?
Well, a sycophantic AI behaves like a yes man. If you suggest a terrible architectural decision for your software, it will just agree with you to be helpful.
Oh, right, just to please the user.
Exactly, which is incredibly dangerous in coding. You want an assistant that will straight up tell you, hey, your idea is going to crash the database.
You want pushback.
Always.
And then we have to talk about the cost, because the pricing is so aggressive, it almost looks like a typo.
It really does.
Through August 31st, they're running this introductory rate. It's $2 per million input tokens and $10 per million output tokens.
Wow.
And even after that, it only rises to $3 and $15. It's also the default model for free and pro plans, and available via API as Claude Sonnet 5. But hold on, we probably need to clarify what these tokens actually mean for a builder's wallet.
Yeah, good idea. So a token is essentially how the AI perceives language. Think of it as a syllable or maybe a fraction of a word.
Okay.
1 million tokens is roughly equivalent to a few thick novels worth of text or thousands of lines of code. Input tokens are what you feed into the AI, like your instructions or your existing code base. That's cheaper because the AI is just reading it.
Got it.
Output tokens are what the AI generates from scratch, which requires vastly more computational power, hence the higher cost. But even at $10 per million output tokens, you are generating massive, complex applications for a pocket change.
It's like hiring a highly capable senior developer who works for pennies. But wait, let me push back here.
Sure.
If an agent is running autonomously in my terminal, is 63.2% accuracy really enough? Or is it going to confidently break my system at a discount? I mean, if a human developer only gets it right 6 times out of 10, the reliability.
That is the exact concern any seasoned developer would have. What's fascinating here is a mechanism called self-checking output.
Okay.
This is the paradigm shift. You aren't just letting a 63% accurate model fire off commands blindly into your system. Sonnet 5 works in a loop.
Like an iterative process.
Yes. It writes a piece of code, runs it in a safe, sandboxed environment, and then it observes the result itself. If the terminal throws an error, the AI reads that specific error log, understands why it failed, and rewrites its own code to fix it.
Oh, so it's acting like its own compiler.
Yeah.
Because, I mean, human developers don't write flawless code on the first try either.
Never.
We rely on the system yelling at us with red text to figure out what we broke. So Sonnet 5 is doing that exact same trial and error process, just invisibly at machine speed before you ever see it.
Exactly. The AI is essentially debugging itself. That self-correction loop drastically lowers the risk of catastrophic errors. It shifts the burden of finding the missing comma or the broken dependency from the human to the machine.
So you have this incredible resource that checks its own work. Assuming, of course, you are legally allowed to hire them, because the geographic reality is that these tools have historically been locked behind strict borders.
Right. The accessibility of frontier models has been heavily regulated primarily through export controls that dictated which countries and entities could physically interact with the APIs.
And today, impartially speaking, the Trump administration lifted those export restrictions on Anthropic's Fable 5 and Mythos 5 models.
Right.
For context, this completely eases a control regime that previously kept those specific models restricted to a narrow, vetted list of U.S. entities. Now those doors are open.
And if we pivot immediately away from the political angle and focus on the creative energy here, this is a massive tailwind. The map of who gets to build with frontier models just expanded globally overnight.
It feels like someone just removed a massive, globally geo-blocked app store. Suddenly, developers worldwide have access to the exact same raw materials as a team in Silicon Valley.
And that democratization of raw materials is where unpredictable innovation happens. When you expand the talent pool like that, you aren't just increasing the volume of developers, you're introducing entirely new problem sets.
Right, local problems.
Exactly. A builder in a developing market might use Mythos 5 to solve a complex local logistics problem that a developer in San Francisco wouldn't even know existed.
So the builder pool is larger, it's cheaper. But what happens when you combine that with the wild capability jumps we're seeing across the rest of the industry this week? Because Anthropic isn't the only one making moves.
Not at all. We are entering a phase where the major players are taking distinctly different philosophical approaches to how an AI should operate.
Let's start with Qwen's AgentWorld model, which dropped back on June 26th.
Oh, this one is wild.
Yeah, this model doesn't just act in environments. It is trained from scratch to simulate 7 distinct agent environments. And it actually beats GPT and Claude on environment response understanding.
That's right.
Here's where it gets really interesting to me. If Qwen is simulating environments before acting, is it essentially playing out scenarios in the Matrix before touching my real-world code?
If we connect this to the bigger picture, yes, that is the perfect analogy. Traditional AI models are just highly advanced autocomplete engines, right?
Yeah, predicting the next word.
Exactly. Qwen's AgentWorld takes a radically different approach by modeling the physics of the computing environment itself. It builds a miniature virtual version of your operating system in its mind.
Wow.
And before it runs a complex multi-step deployment, it plays out the entire scenario in that simulation, watches how the virtual system reacts, observes what breaks, and alters its strategy.
So it's testing the waters virtually so I don't suffer the consequences in reality. But wait, to simulate an entire environment and run those multi-step plans, the AI needs a ton of memory, right? It needs to hold massive context.
Yes, and that brings us perfectly to the updates coming from OpenAI. They are prepping the release of GPT 5.6 next week in both mini and pro variants.
Following that public delay requested by the U.S. government.
Correct. But the defining feature of this release is a staggering 1.5 million token context window, and it is specifically engineered for long horizon coding.
Okay, 1.5 million token context window. We established earlier that 1 million tokens is a few thick novels. So what does 1.5 million actually unlock for someone trying to build software?
So the context window is the AI's short-term working memory. It's what it can keep active in its brain at any given second. With a 1.5 million token window, you are no longer just looking at a single file of code in isolation.
Right.
You can upload your entire software architecture, every API document, the history of every change your team has ever made, your whole database schema. It holds the entire universe of your project in its working memory all at once.
That fundamentally changes the workflow. You aren't asking it to write a specific function anymore. You're asking it how a change in one obscure file will cascade and affect the entire application.
Exactly. And OpenAI also briefly mentioned the release of GeneVenge Pro alongside this.
Which pushes that massive context capability directly into genomics and bioinformatics.
Right. Now, while the proprietary giants are pushing memory and simulation, the open source community is matching that pace with totally different architectures.
Yeah, let's talk about ZAI. They're prepping GLM 5.2. This is a fully open MIT licensed model. It boasts 744 billion parameters and a 1 million token context window, targeting that exact same long horizon coding capability.
Yep.
Now, just so we don't get lost in the specs here, how does the parameter count differ from the context window we just talked about?
Think of it this way. If the context window is the AI's short-term RAM, what it's thinking about right now, the parameters are its hard drive, its long-term knowledge base.
Okay, that makes sense.
Parameters are the microscopic connections that the model formed during its training. So a 744 billion parameter model is incredibly dense with deep, nuanced knowledge about how code works. And the fact that a model this massive is MIT licensed is a structural earthquake.
Because it means a company doesn't have to rely on Anthropic or OpenAI's servers to run it.
Precisely. An enterprise can take GLM 5.2, host it on their own private servers, and build bespoke, highly secure agentic systems. They get frontier-level intelligence without ever sending their proprietary data over the internet.
That's massive for enterprise. And then we have a total pivot away from these massive cloud-based brains entirely.
Yes, Liquid AI.
Right. On June 26th, Liquid AI released LFM 2.5. This model is tiny, only 230 million parameters, and it isn't built on the transformer architecture that powers almost every other major AI.
It uses state space and liquid neural network formulations.
Yeah, and it explicitly targets efficient on-device edge deployment. Why does a non-transformer model matter so much for this?
Well, a standard transformer AI uses something called attention mechanisms. So every time it reads a new word, it cross-references it with every single word it has read previously.
Which sounds exhausting.
It is computationally exhausting. As the context grows, the math gets exponentially heavier, draining massive amounts of power.
Which is why you can't run a powerful AI locally on your smartphone without completely melting the battery.
Exactly. But state space models process information differently. They don't cross-reference everything constantly. They compress information over time, retaining only what is contextually necessary. So it flows more like a continuous river. This allows LFM 2.5 to provide significant intelligence locally on a phone, a smartwatch, or even a factory sensor, completely sidestepping those heavy power requirements.
Okay, so we've talked about the raw intelligence, the massive context windows, models simulating operating systems, tiny models running on our phones. What does this all look like when it hits the real world?
When regular people use it.
Exactly. Let's look at the products launching right now that are built on top of this tech.
Yeah.
Because the tool ecosystem is where all these abstract capabilities translate into actual leverage.
And we are seeing the tedious mechanical parts of building software just being abstracted away entirely.
Like Blink.new and Lovable. These platforms are gaining massive traction. They're essentially AI platforms that turn plain language descriptions into fully deployed apps.
Perfect for first-time devs.
Absolutely. You don't write code. You just give it an English description, and the AI provisions the database, sets up authentication, and deploys it to a web server.
Tools like these are eliminating the chores. Setting up a server, configuring a database schema, those are highly repetitive tasks that don't differentiate your product. By automating that, you let non-technical domain experts launch minimum viable products instantly.
But for people who want to actually design the autonomous agents themselves, there's Architect.new. This is a platform specifically for building intelligent agents.
And their onboarding is brilliant.
Yeah, you start in guided mode for beginners, where it walks you step by step through connecting different AI models. And once you get the logic, you switch to one-shot mode to build entire agent networks instantly.
Architect is doing to AI agents what visual site builders did to web design.
Oh, like drag-and-drop websites.
Exactly. 2 decades ago, you had to hand code HTML and CSS for a basic site. Now, Architect is creating a visual interface for orchestrating autonomous workflows. It moves the skill from writing syntax to designing system logic.
And we're even seeing this move beyond text and code. Tough Tongue AI just released their 2.0 update.
The roleplay engine.
Right. It creates an AI clone with your face and your voice. Sales teams are using this to build live AI teammates that physically join video calls and demo products for you.
Which requires incredibly low latency. It's acting as your proxy in a live, unpredictable human interaction. It has to respond to visual cues and audio interruptions in milliseconds.
It's wild. But looking at this entire ecosystem, from lovable auto-deploying code, from plain English, to agents running our terminals, so what does this all mean for us?
That's the big question.
Do people even need to learn how to code anymore, or are we all just becoming managers of agents?
I think the definition of coding is just fracturing. The mechanical skill of writing syntax, like knowing where to place a semicolon in Python, that is depreciating in value fast.
Yeah.
But the cognitive skill is more important than ever. The skill is shifting from syntax to systems thinking and taste. You have to know what to build and how to string the agents together.
You don't need to know how to swing the hammer, but you absolutely have to know where the load-bearing walls go.
And you have to know if the AI built a good house. You still need domain expertise to understand the problem you're solving. The machine can do the typing, but it can't decide what's actually worth building.
Okay, let's bring this all together. The barrier to entry has completely plummeted. We've got Sonnet 5's aggressive pricing. We've got export unlocking, opening the global talent pool.
Yep.
Massive context windows from OpenAI and Qwen, and these no-code tools like Lovable. The friction between having an idea and shipping a product is basically vanishing.
This raises an important question, though.
What's that?
If the cost of building software and running autonomous agents approaches zero, the limiting factor in the economy is no longer capital. It's no longer coding skill. It's not even geography.
Right, because of the export changes.
Exactly. So the only limiting factors left are your imagination, your taste, and the ambition of the problems you choose to solve. What will you build when the machine does the typing?
That is a fascinating thought to leave you on. Think back to that app idea you had over your morning coffee. The tools are ready, they are cheap, and they're waiting for your instructions. Thank you so much for joining us on this deep dive. Go out there and build something amazing.